Welcome back to my channel. Here we are still working on plane figures with equal area, and we are continuing with this particular topic in technical drawing. So the one that we are going to be working on now has to do with the construction of a quadrilateral that is equal in area to a given reentrant pentagon. Construction of a quadrilateral that is equal in area to a given reentrant polygon. The question that I'm going to use here, I'm going to read it. Please pay attention to the question, then we go on and work on it. How we have to draw a quadrilateral that is equal in area to a given reentrant polygon. The question says that construct a pentagon given that AB equals 80 millimeters, BC equals 100 millimeters, CD equals 70 millimeters, DE equals 40 millimeters, EA equals 80 millimeters, angles CBA and EAB are 120 degree and 45 degree respectively. Let me take the question again. Construct a pentagon given that AB equals 80 millimeters, BC equals 100 millimeters, CD equals 70 millimeters, DE equals 40 millimeters, EA equals 80 millimeters, angles CBA and EAB are 120 degree and 45 degree respectively. So that is the question that we are given here. We are going to construct a quadrilateral that is equal in area to this reentrant polygon. So let's go and see how this reentrant polygon can be constructed. Then we now draw a quadrilateral that's equal in area to it. Now, so the first thing that we are going to do is to draw a horizontal line. So here we have a horizontal line, so like this, okay? We have this horizontal line. So on this horizontal line, we are going to take a measurement of AB that is 80 millimeters long. So we take measurement of AB, which is 80 millimeters long. So this is point A, and here we have this to be point B, 80 millimeters apart. So I'm going to write A at this point. So this is point A, okay, and then this is point B. Okay, we have it here. The next thing that I'm going to do is that we are told that BC is 100 millimeters. So I have to take a measurement of 100 millimeters on the ruler. So I'll take 100 millimeters here. So with the compass, so we take 100 millimeters. So this is 100 millimeters. So as we have it here, so I'll put it at this point B here because we are told that BC is 100 millimeters. So I will draw an arc here, okay? I will draw an arc here, so like this. So we have this arc drawn. Then the next thing that we are going to do is that we are told that CD is 70 millimeters. CD is 70 millimeters. But before we can continue with this, we need to locate point C here. First of all, we have that angle CBA is 120 degree. Angle CBA is 120 degrees. So we need to draw this angle first so that we can get point C on this line. So I'm going to make use of my compass. So putting the pinpoint here at point B and extending the pen point to a convenient radius, I will draw an arc here like this. Okay, I'll draw an arc here. Okay, then I will take this same radius, put the pinpoint here where the semicircle touches the line, and I will take out angle 60 degree out of angle 180 degree. So then I'm going to draw a line from this point, passing through the point where the arc touches the semicircle, and then wherever it touches on this arc will be point C. So it goes like this, okay? So we draw like this, okay? So here we have what we have, this point where this line touches this arc. This is point C here. So look at it. So this is point C. Now, the next thing that we are going to do is that we have that DE is 40 millimeters. So D is 40 millimeters. But before that, we have not located point D. We need to get CD, which is 70 millimeters. So with the compass again, I will take a measurement of 70 millimeters on the ruler. 70 millimeters on the ruler. So I have this to be 70 millimeters here. So this is 70 millimeters. Okay, so we have 70 millimeters here. So I'll put the pinpoint here at C, and I will make an arc, so somewhere here like this. Okay, make an arc here. Okay, so we have an arc here, so we have this now. All right, so we have not located point D, so we are still going to locate it. We have to do something. So what I'm saying is that we need to draw an angle of 45 degree at this point A here, because we are told that angle EAB is 45 degree, as I read in the question. So we need to construct that angle 45 degree, and to do that we need to put the pinpoint of the compass here, and then we draw a semicircle. So we draw a semicircle like this. Okay, so this semicircle is 180 degree, so we have to bisect to get 90. Then now bisect that 90 to get 45. So I'm bisecting this, so we put the pinpoint at this point here, and then we also put it here at this point, and we draw an arc. So we are going to draw the bisector of this 180 degree. So we draw the line, so it goes like this. Okay, then so here we have 90 90, so we need this 90 inside here, so we are going to bisect this 90 to get 45 degrees. So I'm going to bisect it like this, and then we'll put the pinpoint here, so we also draw a line. So I'm going to draw a line from point A, so passing through the point of intersection of the arcs, and it goes like this. So here we have this. Okay, then now in the question, so we also have that EA, line EA or side EA of the reentrant pentagon is 80 millimeters. So I need to take a measurement of 80 millimeters here on this ruler with the compass. So this is 80 millimeters. So here we have 80 millimeters here. So this is 80 millimeters. So I put the pinpoint here at this point, and I'll make an arc here. So make an arc here. So this point is point E. So here we have point E in here. So we put it here. So this is point E. So we have point E here. Okay. So now, so since we have located point E, we can now locate point D, as we are told in the question that DE is 40 millimeters. DE is 40 millimeters. But CD is 70 millimeters, and that is what we have done from here to here by drawing this arc. Okay, 70 millimeters from this point. We have drawn this arc. Okay, so what we have to do now is to take a measurement of 40 millimeters for DE. 40 millimeters for DE. So we take 40 millimeters here on the ruler. So this is 40 millimeters. So putting the pinpoint here at point E, so we can make an arc here. So we make an arc here. Okay, so this particular point where this arc touches the arc that we drew from point C to get this, which lead us is 70 millimeters. So this point here is point D. So we have this point to the point D here. Okay, so now, so we can now join DE together to form this reentrant polygon. So this is the reentrant polygon now. So we have this reentrant polygon A, B, C, D, E, and then we also join C and D together, okay, to obtain side CD. So this is it. So we have this now. All right, so this is a reentrant polygon that is given to us. Do not forget that this angle here, so this angle is 120 degree, as we are told in the question, while this angle here is 45 degree, as we are told in the question. So let's take note of that. So we have constructed this reentrant polygon now. So let's go and work on how we can draw the required quadrilateral. So what we are to do now is that we are going to join AD together with a straight line. We join AD together with a straight line like this. So we draw a line from A, so joining it with point D like this. Okay, now we are going to draw a line from this point E to touch this line AB, and that line will be parallel to this line AD. So what we are to do is very simple. So set the set square, set it along this line AD, and put your ruler under it like this. Okay, then we now shift the set square, we shift it to point E like this. Okay, then we draw a line from here to touch this line AB at this point. Okay, so this point here is point F. Okay, so this is point F, do not forget that this line EF is parallel to line AD. So we need to show that, okay? So we have this now. So now to now bring out the quadrilateral that will be equal in area to this re-entrant polygon ABCDE. So it's very simple. So what we have to do is that we are going to join this point F together with point G. So we join F together with point G like this, okay? All right, so we join F with point G as we have it here, and then we are going to make this line BF to be a thick line, okay? So which is another side of the quadrilateral. So DF is a side of quadrilateral and BF is a side of quadrilateral, and also BC is also a side of the quadrilateral like this, and also CD is another side of the quadrilateral. So now the required quadrilateral that is equal in area to the given re-entrant polygon is quadrilateral BCDF. It's as simple as I've done it here. All you have to do is to practice. When practice this, become a master at this work. Thank you. Keep on practicing, and God bless you.